Did you know that every triangular Doritos chip starts its journey as a humble corn kernel that undergoes 9 separate manufacturing stages before reaching your fingertips? The transformation process combines ancient techniques dating back thousands of years with cutting-edge modern technology most people never see. In this exclusive factory tour, we'll reveal exactly how 70,000 bags of Doritos are produced daily, showing you the surprising engineering behind that perfect crunch and distinctive flavor coating. From the specialized corn varieties carefully selected for their starch content to the precision-controlled nixtamalization process that changes the very structure of the corn, this is the real story behind America's favorite chip. That ancient nixtamalization process is just the beginning of a transformation so precisely engineered that it borders on scientific artistry. Inside those massive cooking vessels at the Doritos factory, a dance of temperature and timing plays out with remarkable precision. The corn kernels must be heated to exactly 93 degrees Celsius, 200 degrees Fahrenheit, for a strictly controlled 4-minute period, not a moment longer or shorter, initiating a sequence of changes that will ultimately result in the perfect chip. What might seem like a simple cooking step is actually the start of a meticulously calibrated 12-hour process. After the initial heating, the corn is transferred to specialized soaking tanks where the alkaline solution continues its work. Here, the chemical reaction steadily breaks down the outer hull, while the kernels gradually absorb moisture until they reach precisely 45% water content. This exact percentage is crucial. Too dry and the corn won't grind properly. Too wet and the final chips will have the wrong texture. When the soaking phase completes, the transformation shifts into higher gear. Powerful jets of water blast away the now loosened husks, preparing the kernels for their next metamorphosis. The clean kernels then travel to grinding stations featuring massive millstones that pulverize them into a smooth, homogeneous dough known as masa. This isn't your typical kitchen grinding process. These industrial millstones work with incredible force to achieve the perfect consistency, reducing hard corn kernels to a fine, workable medium. Quality control during this grinding phase is relentless. Technicians continuously monitor the masa's moisture level, temperature, and texture profile through the production line. Even slight variations in any of these parameters could dramatically affect the final product's signature crunch and flavor characteristics. The monitoring systems use both automated sensors and regular manual checks to ensure consistency, batch after batch. From here, the masa embarks on a journey through a series of precision rollers that transform it into thin, continuous sheets several feet wide. These rollers are calibrated down to the millimeter, as the exact thickness of these sheets directly correlates to the finished chip's texture. Too thick, and the chip becomes dense and hard. Too thin, and it becomes fragile and burns during frying. The most visually impressive part of the process comes next, as the sheets encounter the triangular cutting dies. These specialized machines stamp out an astonishing 6,000 individual chips every single minute, resulting in more than 8 million triangles in a 24-hour production cycle. The cutting process is hypnotic to watch. A continuous flow of dough entering one side and a perfectly aligned army of triangles emerging from the other. In an impressive display of efficiency, not a scrap of dough goes to waste. Any material left between the triangular cuts is immediately collected and recycled back into the production process, maintaining maximum efficiency and minimizing waste throughout the factory. The freshly cut triangles then face a crucial transformation inside a specialized 3-level oven heated to several hundred degrees Celsius. Here, timing is everything. The chips spend exactly 16 seconds inside this precision oven. This brief but intense heat exposure seals the outer surface while trapping moisture inside, creating microscopic air pockets that give Doritos their distinctive texture and satisfying crunch. Those 16 seconds of precision cooking are just the prelude to what many consider the most critical moment in a Doritos journey. As the preheated triangles exit the specialized oven, they immediately enter massive continuous fryers where vegetable oil is maintained at exactly 182 degrees Celsius, not 181 degrees Celsius, not 183 degrees Celsius. The temperature control must be flawless, as these thin corn chips spend precisely 55 seconds submerged in this carefully controlled bath. The margin for error here is remarkably slim. If the chips remain in the oil for even a few seconds too long, they burn and develop bitter flavor compounds. Too short, and they retain excess moisture that ruins the signature crunch. Even a minor temperature fluctuation of just a couple of degrees can mean the difference between perfect batches and thousands of dollars of wasted product. Factory engineers monitor these parameters with obsessive attention, using advanced thermal sensing equipment that feeds real-time data to control systems. As the perfectly fried chips emerge from their oil bath, they're immediately transferred to specialized mesh conveyor belts. These belts serve a dual purpose. They drain away excess oil while the gentle vibration mechanisms carefully move the now fragile triangles forward without causing breakage. At this stage, the chips are particularly vulnerable, having transformed from dense dough into delicate, crispy structures. Before the flavor magic happens, the chips undergo an ingenious intermediate step. A fine mist of rapeseed oil is applied across their surfaces, creating a slightly tacky exterior. This thin oil coating isn't there for flavor. It's a crucial engineering solution that ensures the powdered seasoning will adhere evenly to every square millimeter of the chip. Without this adhesive layer, much of the flavoring would simply fall off during packaging and transport. The actual seasoning is where science meets culinary art. While the exact recipes remain closely guarded industrial secrets, we know the flavor dust contains various cheeses including cheddar, Parmesan, and Romano, along with a proprietary blend of spices. Food scientists also incorporate flavor enhancers like monosodium glutamate and preservatives that ensure shelf stability without compromising taste. The application of this seasoning happens inside massive rotating drums, where the chips tumble gently as the flavoring cascades down. The engineering is doubly clever here. Not only does the rotation ensure even coverage, but the chips themselves function as shock absorbers against each other, preventing breakage during the tumbling process. The drum's rotation speed is carefully calibrated to maximize flavor adhesion while minimizing damage. After receiving their flavor coating, the chips embark on a cooling journey along 30 meters of specialized conveyor belts. This extended cooling path isn't excessive. It's precisely calculated to allow the chips to reach the optimal temperature for packaging. Too warm, and condensation would form inside the bags, making the chips soggy. Too cool, and the packaging machinery might crush them. The final stage involves some of the most sophisticated food packaging technology in modern manufacturing. Machines equipped with 14 precision scales weigh exact portions before directing them into waiting bags. But what happens next is perhaps the most ingenious step of all. Instead of simply sealing in air, the packaging machines flush each bag with nitrogen gas, completely replacing the oxygen. This nitrogen cushion serves two critical functions. It prevents oxidation that would make the chips stale, while simultaneously creating a protective air pillow that shields the fragile triangles during shipping and handling. Behind every Doritos chip lies an intricate dance of engineering precision. What appears as a simple snack actually represents a feat of manufacturing excellence, where uniformity isn't accidental but meticulously designed. The production facility operates like a finely tuned orchestra, with specialized machinery ensuring that each triangular chip maintains identical dimensions, flavor profiles, and that signature crunch consumers expect. Quality control isn't merely a final checkpoint, but an ongoing process embedded throughout production. Engineers monitor operations at multiple inspection points, with computerized systems analyzing thousands of chips per minute for color consistency, proper seasoning distribution, and structural integrity. This vigilance explains why a Doritos chip purchased today tastes remarkably similar to one from last month or even last year. The engineering marvel extends beyond the chips themselves to the entire production ecosystem, where billions of identical chips emerge from raw ingredients through a harmonized sequence of precision machinery, calibrated timing, and rigorous testing protocols. It's a testament to modern food manufacturing that something as seemingly simple as a corn chip represents such a complex convergence of science and engineering.